Let's take a look at some graphics properties. All figures consist of different objects, each of which is assigned an object handle. So the various plot functions that you can have, they all return a handle for the plot object, which can then be stored in an object variable. This object will be valid as long as the object exists. So in other words, don't close the figure window. If you close the figure window, then all of the objects go away. Objects within plots or within the figure window include things that are called graphics primitives, and these consist of things like line and text, and also the axes that are used to orient the objects. The computer screen is called the root object, and that can be referenced using the function groot. All of these objects are organized hierarchically, and there are properties associated with each object. In object-oriented programming, a parent comes before its children in the hierarchy. Generally, children inherit properties from the parents. There are actually several common terms for this. You can call them parent and child, you can call them base and derived, and you can call them superclass and subclass. The figure window and the axes are parents. The axes are used to orient its children, which includes plot objects and core objects. So to go back through that again, you start with the screen, the root object, which is the screen. Within the screen, you have the figure window. Within a figure window, you have the axes, and then the axes are used to orient things like lines and text. By creating a figure window and storing its handle in an object, some of the properties can be seen. So if we just say F to get a figure window, then we can see that it's the first figure window. It has some properties. The number is 1. It's the first figure window. We haven't given it a name, so the name string is empty. It has a color, it has a position, it has pixels, and you can click on the Show All Properties, and that will bring up all of the properties. So by default, you just get a few properties, and then you can click on this to get actually all of the properties. Properties can be referenced, both to look at them and to modify them, using the dot operator. So for example, f.name refers to the name of the figure window. That is, as long as we still had that figure window and we still have our object called f. So the way it works is that you give the name of the object, and then the dot, and then the name of the property within the object. So again, an example is f.name. Another method for looking at the properties and modifying the properties using the functions get and set. This is no longer encouraged. These are functions that were used earlier versions of MATLAB, but in the version 2014b, basically all of the graphics system was completely changed and object handles became actually objects before they were numbers, and before you had to use get and set. But now the preferred way of doing it is to use the dot operator. So we'll go through both methods. By assigning the result of the get function to a variable, you can actually get access to the properties in a different way. What this does is it creates a structure in which the property names become field names. So if I say get f and store that in a variable, then the variable is now a structure. So now when I say fstruct.color, that's using the dot operator. That's completely different from the other method. So the other method was using the name of an object dot the property. This is actually creating a structure and referring to the field name within the property. The get function can also be used to get a specific property. So instead of just saying get f, I could say get f, comma, and then the string color, and that will give me the color property. The set function can be used to change properties. So when you call set, you pass to it the handle of the object, and then you can pass property names and values in pairs. So the property name is a string, comma, its value, and then you could have another name, another property name, comma, its value, and so forth. So it's set, the name of the object handle, and then pairs of property names and their actual values. So properties can be set when you're creating the object to begin with, or later using the set functions. So for example, if we still had our object f, then we could say set f comma position and then give it a new position vector. But a better method of doing that is to use the dot operator. So we say f dot position and then assign to that a position vector. Plot functions return a handle for the plot object. So before we've just said plot, but the plot function actually returns a handle, and we can store that in a variable. So if I create a variable x and then plot x and sine of x and store that in a variable, we'll see first of all what it does is it creates something using the line primitive. And again, it shows us some of the properties by default: the color, the line style, which is straight line segments between the points, the line width is 0.5, the marker size. You can also see that we have x and y data, but not z data, so that's a 1 by 0 double. So this is a two-dimensional plot. We only have x and y values, not z values. And again, if you want to see all of the properties, then you can click on this Show All Properties. So it just shows a few of the properties by default, and then if you want to see more properties, you can click on the Show All Properties. So using the dot operator, you can display properties and you can also modify them. So for example, one of the properties of my plot handle, phan, is parent. So if I say phan.parent, we'll see that that's actually axes. So again, we have a figure window, and then within the figure window you have the axes, and then within the axes you have the actual line. So the axes, you see some of its properties. So another thing we could do is we could refer to the line width. So phan.linewidth, and then if we wanted to change the line width from what it was before, we could say phan.linewidth gets the value of 2. So you can again use the dot operator to display properties and also to modify them by assigning new values to them. One property in particular that I want to mention is the color property. The color property is given as a vector that stores 3 numbers representing the red, green, and blue components in the range from 0, which means none of that color, to 1, which is the brightest possible. So it's red, green, blue in that order. So for example, if I have 1, 0, 0, that's the brightest possible red, no green, no blue. So in other words, that's just the color red. So similarly, 0, 1, 0 is green, 0, 0, 1 is blue. 0, 0, 0, the absence of any color, is black. 1, 1, 1, the combination of all the brightest possible colors, that actually gives you white. And then something in between, like for example 0.5, 0.5, 0.5, is the color gray. Some useful functions that are built in are the GCF function, which gives the handle for the current figure, so it stands for get current figure, and the GCA function, which returns the handle for the current axes, so that stands for get current axes. So this is a fairly long sequence of statements. What I'm doing is creating an x vector, and in the first figure, figure 1, I'm getting a plot of x and sine of x, and storing that in a handle variable called p1. And then I'm getting a second figure window and storing a second plot, this time x and cosine of x, and storing the handle of that plot in a second variable called p2. So the second figure is now the current figure. So if I say GCF, the current figure is the second figure. You can see that it says figure 2 and some of its properties. If I use a logical expression, see whether the current figure is equal to GCF, then that tells me that it's logical true. And again, the current figure, the children of that is going to be, so the children property is going to be the axes. So that is going to be equal to GCA. So again, GCA will get the current axes, and so that's going to be a true expression.